This is the number 6 final review for first semester geometry. It comes from chapter 5.6 about angle bisectors and perpendicular bisectors. We're going to start with angle bisectors first. This is theorem 5.3, angle bisector theorem. If a point is on the bisector cuts something into two congruent parts of an angle, then it is equal distance from the two sides of the angle. So if you have this, here's your angle, and it is cut by the angle bisector ray AB, that means that angle A and angle 1 and angle 2 are congruent. Then it also means that segment CB and segment CD, the segment CB and segment BD are congruent. One of the other things you should also notice that the angle that will be formed down here between this angle bisector and the side is going to be a right angle. So these two sides are congruent. These two angles right here, 1 and 2, are congruent. All right, let's go ahead and move down to you doing some examples. So this is problems 1 and 2. You've done this before. So I think you can do it without me actually doing it first. So we'll go ahead and find the value of x, and then find the value or the length of segment LK. And on number 2, also find the value of x, and then find the degree measurement of angle STV. When you're finished, go ahead and turn it back on again and check your answer. Go back and look at the first page of the notes or of the recording, and that will help you if you're having any troubles. All right, on number 1, you have angle LMN. It is being bisected by ray MK. I know these don't look properly congruent, but they are. I'm telling you with tick marks they are. We know that because it's an angle bisector, angle NMK is congruent to KML, and that means that segment NK is congruent to segment LK. So if they're congruent, they'd be equal. So LK is 2x minus 1. KN or NK is x plus 9. We want to collect the variables on one side, keeping the coefficient possible, or keeping the coefficient positive if possible. So we're going to subtract x or 1x from both sides. We end up with 2x minus x, which is x minus 1 equaling 9. Add 1 to both sides, x is going to equal 10. Now once you have that, we're asking for LK, so 2 times 10 would be 20 right here, minus 1 would be 19. Just to make sure I'm right, I'm going to put the 10 into the KN or NK segment, and 10 plus 9 is also 19, so we've confirmed that they are congruent. All right, for number 2, we know that TV, ray TV, is an angle bisector because segment SV and segment UV are both 8, meaning they're both congruent. If that's true, then these two angles have to be congruent if ray TV is an angle bisector. So angle STV is congruent to angle VTU. So 6x plus 3 equals 27 degrees. Subtract 3 from both sides. 6x equals 24 degrees. Divide both sides by 6 using the division property of equality, so x equals 4. Now, we know that STV has to equal 27 because the two angles are congruent. However, let's just make sure that the x value is correct. So we substitute it into the x position. 6 times 4 is 24, plus 3 is 27 degrees. And now we're going to move on to perpendicular bisectors. Okay, theorem 5.4 is the perpendicular bisector theorem. And if a point is on the perpendicular bisector, so for instance, C and M are both on a perpendicular bisector of the segment AB. M is equidistant from B as it is from A, so these two parts are congruent. But you have another point that is also on the perpendicular bisector, and that is C. So from A to C and from C to B will also be congruent, which is what you see in the then statement. All right, so we're going to go ahead and use this. Let's make one more statement that AC, segment AC, is congruent to segment CB. That's what came out of the if-then statement. We know AM and MB are as well, but this was, we knew it was a perpendicular bisector by telling you that AM and MB are congruent. Okay, let's go ahead and use it. I think you've done enough of this that you can try them on your own. If you have trouble, go back and look at the theorem. And when you're finished, turn on the recording and check yourself. Okay, so number 3 and number 4 are both perpendicular bisectors. You can see that the rays in the first one CD and in the second one QS bisect the segment in the first one BA and the second one PR because they are giving you congruent symbols for BD and DA, for PS and SR. You also know it's a perpendicular bisect because you have a right angle symbol given. And what we know from the theorem is that any point that lies on that bisector, so in this case QS, will be equidistant from the endpoints. So Q and R will be congruent, and P and Q will be congruent. So QR segment will be congruent to QP segment. And over here, you know that BD is congruent to DA. Therefore, this point C is going to be equidistant from this endpoint as it is from that endpoint. So CB is congruent to CA. Go ahead and solve these, then turn the recording back on to check your answers. Okay, so looking at CB, which is x minus 4, which is congruent to CA, which is 3x minus 10, you initially, or in the beginning, collect the variables on one side, trying to keep the coefficient positive, so we're going to subtract x instead of subtracting 3x. We end up with negative 4 equaling 3x minus x is 2x minus 10. We add 10 to both sides. Negative 4 and 10 is 6. We're left with 2x on the right. Division property of equality has us divide by 2 to isolate x. So 2x divided by 2 is x, 6 divided by 2 is 3. You can plug it in and make sure that you are correct. That's not a good sign. It came out as a negative. Let me go ahead and, you got the idea, but you should never come out with a negative. I should have checked this first. 3 minus 4 is negative 1. 3 times 3 is 9. Minus 10 is negative 1. This would not be solvable because we've got a length of a segment and it can't be a negative value. We'll ignore that for right now and go over to this next one, and I'll change it out to something that's going to be appropriate. Okay, so on this one, we've got 5x is PQ, and we've got 3x plus 8 is QR. They are congruent, so 3x plus 8 is QR, and 5x is QP. We collect the variables on one side, so we subtract 3x from both sides. 8 equals 2x. And then we divide both sides by 2 using the division property of equality. 2x divided by 2 is x, and 8 divided by 2 is 4. We'll check this, plug it in. 3 times 4 is 12, plus 8 is 20. 5 times 4, substituting in the 4 value for x, is 20. So that comes out correctly. Let's go back. I'll change out these numbers just to make it work better. So let's pause it, and then give me a minute, I'll change it. My apologies. I made them sides that work now. Segment CB is x plus 7. And it's going to be congruent to segment CA, which is 2x minus 3. Go ahead and solve that, and then turn on the recording again, and now you'll get a problem that comes out with sides that are not negative values. Okay, so once CB was x plus 7, CA was 2x minus 3. You subtract x to keep the coefficient positive, which gives you 7 equals x, or 1x minus 3. You add 3 to both sides to isolate the x using the addition property of equality, and you end up with x equaling 10. We're going to substitute that in mentally to the x value, so 10 plus 7 is 17. Then we put it in here. 2 times 10 is 20, minus 3 is 17, so we know that x value is correct. All right, that is the end of this recording.